check one, check one. Right. Good evening, everybody. Back again with the interactive session. Right. This is our usual time slot for the interactive session, the usual grade level session. Today, specifically, we are starting a new section, Unit 8, heat changes associated with chemical reaction. In short form, we call it energetics. Before we start, quickly tell me, is all the DOs perfect? Send to the WhatsApp group, and because today YouTube live is going, plus the Zoom stream is going. So both the sides I need to manage. Yeah, Zoom also you can send, Zoom people can send here. Plus, mainly we'll be using the WhatsApp chat. Quickly tell me, is the video, audio all clear? Perfect. Perfect. Crystal clear. Clear, ne? Hurry. Right. Correct. I hope all of you have the tute. Before that, physical students. If you are one of my physical students, Candy Hari, Colombo Hari, Gol Hari, whatever physical students, you don't need to join because this will be done in the physical class. Already at Kotihena we started, Candy we started, Gol by next week we will be starting, right? In the on physical students do not need to join, but if you join, that's okay because it will be a revision for you. Same thing we are doing in the physical class also. It will become a revision for you because today mainly we'll be discussing some questions. Taking the question for the perfection of the question, you can do with me today as well as with physical class. Hurry. We just know that I'm waiting and y'all know voting also from morning and I don't know whether you all bath also today. From morning, it's okay to join at least online class and do some questions and go with me. Need. Hurry. Right. I hope all of you have the tune. If you don't have the tune, that doesn't matter much. At least you can use a writing book and copy the notes. Later on, you can take a printout of the tune and you can copy it to the tune. Right? That doesn't matter. Just focus and listen. Right. This is the last lesson in your part one book. Heat changes associated with chemical reaction. One of the longest heading but shortest lesson. Heat changes associated with chemical reaction lamani. In short form, we call it energetics. More become different lesson in chemistry. Until now, whatever you learned in chemistry, what can become opposite. This is totally a different section of chemistry. Guaranteed you can expect questions from this for your final O-level exam. Such an important lesson. Without talking a lot, we'll start the lesson. I'll start with the heading itself. Heat changes associated with chemical reaction. Heading is itself like an essay. Heat changes associated with chemical reaction. Right. What are we going to learn in this lesson? Lamai. Chemical reaction. You all already have learned about chemical reactions. You have learned about chemical reactions. Look very carefully. Chemical reactions. What happens basically in a chemical reaction? There are reactant, one reactant or several reactants. They react together to form the product or products. This is what basically happens in a chemical reaction. Reactants are there, they become products, they convert into product, they form the products. This is what we know. Now, when a chemical reaction is happening, when reactants are converting into product, not only the reactants are undergoing a change, also there is a change in the energy. Until now you learned, during a reaction, only reactants are undergoing a change and they are forming product. Now suddenly from nowhere, I am coming and telling you, during a reaction, not only the reactants are converting into products, But there is a change in the energy. Like the overall energy of the system will undergo a certain change there. There is a change in the energy. Mainly what energy? Heat energy. Mainly there is a change in the heat energy. For example, you take a beaker, put some hydrochloric acid, HCl, put a piece of magnesium. It will react. Reaction will proceed. Meanwhile, you touch the beaker, you will feel that the beaker gets hot. Why? Because there is a change in the heat energy there. Heat is released out. That's why beaker becomes hot. There are some reactions. During the reaction, system will cool down. When you touch the system is cooled. So during a chemical reaction, there is not only a change in the reactants, but there is a change in the energy. Mainly what energy? Heat energy. That is what we learn in this lesson. Clear? I am asking whether the heading is clear, because first of all, you should understand the heading. Otherwise, you can't do this lesson. Bingala, tell me. Is the heading clear? WhatsApp group also use YouTube पे contact भी लेंगे लोग. Is the heading clear? Practically. Right. Perfect. Now back to the board. Eyes on the screen, ears on the speaker. Listen very carefully. So now we know during a chemical reaction, not only reactants are undergoing a change, but also there is a change in the heat energy there. What kind of a change can happen? What kind of a change can happen? Lamai, only two types of changes can happen. What are the two types of changes? One, sometimes heat can be released. Possible during a chemical reaction, heat can be released out. Beaker can become hot. Otherwise, heat can be absorbed. Heat can be absorbed. Otherwise, heat can be absorbed. When heat is absorbed, what will happen is beaker become cool down. Sir, when the heat is absorbed, how come the beaker become cool down? Yes, Lamai, because from outside, when the heat is absorbed, from outside, when the heat is absorbed, heat is gone. Heat is gone. When heat goes, outside become cool down. When you touch, it's cool. So only two types of things can happen. Echo heat can be released during a chemical reaction. Echo heat can be released during a chemical reaction. Heat can be absorbed during a chemical reaction. The chemical reactions in which heat is released is called as exothermic reaction. The chemical reaction in which heat is released is called as exothermic reaction. Open the mouth and tell, these are new words for you. Chemical reaction in which heat is released is called as exothermic reaction. The chemical reaction in which heat is absorbed is called as endothermic reaction. Endothermic reaction. That means depending on the heat change associated with chemical reaction, there are two types of chemical reactions. What are the two types? Exothermic reaction, heat is released. Endothermic reaction, heat is absorbed. Again, depending on the heat change associated with chemical reaction, there are two types of chemical reaction. Exothermic, heat release. Endothermic, heat absorbed. Only memorize one entry, because when you memorize two things, you will get confused during the exam. That usually happens in these kinds of confusing things. The things that goes together, memorize only one. Opposite is the other. Exothermic. Memorize that. Deeply memorize that technique. Exothermic reaction. Heat is raised. Then opposite is endothermic. Memorize that. Again, exothermic reaction. Heat is raised. Opposite is endothermic. Take your view. Depending on the heat change associated with chemical reaction, there are two types of chemical reaction. Write down exothermic reaction, endothermic reaction. Exothermic reaction, endothermic reaction. So have you completed this lesson in Faraday candy? No, it's not completed in Faraday candy. We started this lesson, not completed. So if the heat is absorbed, will the beaker cool down? Are cool down getting heated part? I will deeply explain it when I go deeply into this. When I deeply explain about exothermic and endothermic, I'll be explaining. Don't worry. Okay, no? Now you'll be wondering, Anisa, in grade 10, you learned about types of chemical reaction. There are four types of chemical reaction. Chemical combination reactions, chemical decomposition reaction, single displacement reaction, double displacement reaction. Those are what? Those are types of chemical reaction. These are types of chemical reaction depending on the heat change. So that word is used there. Depending on the heat change, we divide chemical reaction into two. But generally, we can divide chemical reaction into four. That is chemical combination, chemical decomposition, single displacement, double displacement. Those are types of chemical reaction. No any dependence there. Here we are specifically telling if it depends on heat change, then two types, exothermic and okay. First we will go to exothermic reaction. First going into exothermic reaction. Listen very carefully. Exothermic reaction. You all already know. During exothermic reaction, tell me, heat is released to absorb. Heat is what happens to the heat? Put it to the mind. Deeply put it to the mind. Exo means my guaranteed heat is raised. Heat raised. Heat raised. So you as an observer, what you will observe during a chemical reaction in which exothermic reaction is taking place, what you will observe in the system, in the reaction system, right? Reaction is happening. During the reaction, heat is released out. Heat is released out. When heat is released out, surrounding will become heated. Correct? When heat is released out, surrounding become heated. Then when you touch it, it will be hot. Temperature is hot. That is what we feel. When we touch it, we feel that the system is hot. So what is exothermic reaction? Chemical reaction in which heat energy is raised. Exothermic reaction. Okay. Take exo under the write down. In the dotted line write down. Chemical reaction in which chemical reaction in which chemical reaction in which heat energy is released. Heat energy is released. Is exothermic reaction. Exothermic reaction. Exothermic reaction. Perfect. Now listen. Now that idea is there in your mind. Now we are going to go a bit deeper. A bit deeper. Listen very carefully. Right. Exothermic reaction. I'm going to write a general representation on exothermic reaction. Right. Listen very carefully. Exothermic reaction. It's also a chemical reaction. During chemical reaction, reactant or reactants convert into products or products. This happens in any chemical reaction. Reactants are there, they react together, they form the product. Any chemical reaction, reactants are converting into products. Now during exothermic reaction, heat is released during the reaction. Heat is released during the reaction. Now listen very carefully. Heat is released means what does that tell us? Heat released out. Heat is given out. Heat is like produced and given. Some kind of a meaning is coming like that. During the reaction, heat is like produced and given. For the heat to be released out, heat should be produced and given. Something like that is meaning that heat released and heat is like produced and given. In a chemical reaction, if something is produced, it is like a product. So therefore, in exothermic reaction, in the product side, we are going to write heat. Why we write heat in the product side? Because heat is produced and given. During this reaction, together with the product, heat is produced and given out. It is given out. That's why we write it in the product side. So the general representation for an exothermic reaction is reactant convert the product. On the product side, you additionally write. That's how you write down exothermic reactions. Heat is given. Okay. Now listen. Why is the heat energy given out? Heat is an energy. Why is the heat energy released? Why is it given? See now, we give something when we have it in excess, nail. Just think. Now let's take you have lot of chocolates. You have a lot of chocolates. When you have a lot of chocolates, if your heart is good enough, we give it to someone else. Isn't it? When we have something in excess, we try to give it. We try to release it. This reaction also see. Heat is released. Heat is given out. Why is the heat energy given out? That is because reactants are having lot of energy. They have excess energy. Products are having less amount of energy. Now think, these people have lot of energy. Here there is less amount of energy. That means there is an excess. that excess is only. So in an exothermic reaction, reactants are having more energy. Products are having less energy. So when reactants convert into products, there is an excess energy here. That excess energy is only released as heat. For example, now think, reactants are having about 5,000 joules of energy. Products need only 3,000 joules of energy. Mathematically think, reactants have 5,000 joules of energy. Products need only 3,000 joules of energy. Then how much of energy will be released during this reaction? How much is the excess there? How much will be released? Mathematically think, don't think scientifically. Mathematically think, initially you have 5,000, only 3,000 is needed. Remaining how much? Remaining how much is released? Everyone, practically think. Don't think scientific, don't think like scientists now. Practically think and tell me the answer. Perfect. 2,000. 2,000 is an excess energy. What to do with that? Release it. When the reaction, that is excess energy. No need that to release it. That's why ether becomes hot. Okay, maybe practically if I tell example for this, during a function, wedding function, interactive class students know, wedding function. Yesterday's wedding. And for the wedding, you are going to take some dress. Right? Beautiful dress, gorgeous dress. And you, wow, beautiful dress. Right? A dress. Now you don't have money. Maximum you will have about 20 rupees collected, remaining money that mother gives or father gives for the school. A money you have, you can't buy a dress. You are going and asking your father or the mother, honey, I need to buy a dress. I don't have a dress. Father gives you some money. Let's say he is giving you 5,000 rupees. 5,000 joules then, 5,000 rupees. The dress that you wanted is only 3,000 rupees. How much is the excess there? How much is the excess? 5,000 he gave, only 3,000 you need. To attend the wedding, only 3,000 you need. How much is excess? 2,000. We go and give it to our father. Only father, that only 3,000 rupees for the dress, remaining 2,000 you keep here. On the Putala again, on the Pullega money, we go and give it. That is happening. So initially there is excess. When the conversion is happening, products need only a little amount of energy, that excess is released. I was waiting for a good question. I will itself ask the question and answer. Right. Now, why is the reactants having energy? So from where did this energy come? Why is the reactants having some energy? Why is the products having some energy? Until now, in chemistry, we never learned about this. Reactants have some energy. Products have some energy. From where did this energy come? Where is this energy present? Lamai, listen very carefully. Reactants, products, they have bonds. Now, for example, sodium chloride, Na plus is bonded to Cl minus. What if this bond means? That bond has some energy in it. This bond has stored energy in it. During a chemical reaction, you have to break this bond. From that only a new compound is formed. We break bond and form new bonds during a chemical reaction. Now, for example, HCl reacted with magnesium. What is the product form? Magnesium chloride and hydrogen gas. What is happening here? Hydrogen is bonded to chlorine. Now what is happening? Magnesium 2 plus is bonded to Cl minus. Can you see? We have to break this bond. We have to form new bonds here. In the bond, there is energy. So to break the bond, when forming new bond, there is a change in the energy happening. Sometimes reactants are having lot of energy in the bond. Products need only little bit of energy in the bond. That means there is an excess energy. Where to put that energy? That is only released as energy. So in the bond, there is energy. You break bond, you form new bond. You break bond, you form new bond. During that, guaranteed there is energy change happening. That is what is released during exothermic reaction. Clear? Hmm? Those things they won't ask in the exam. Where the bond has energy, how much of energy they have, those things they won't ask in the exam. But this one you should know anything. There's no point in studying this lesson. Right? So keep that in mind. That energy only undergoing a change. Right? So as a summary, what you need to know during exothermic reaction, reactants have more energy, products are having less energy. That remaining energy is only released as what? Heat energy. Released as heat energy. For example, I erase these things. For example, for example, what shall we take? Magnesium, solid, reacted with HCl, aqueous. Product form, now we wrote it. Magnesium chloride, aqueous, hydrogen gas. I'll balance the equation. 2 hydrogen, 2 chlorine, 1 nitrogen, 1 chlorine, 2 there. Lamai, this is an exothermic reaction. So during this reaction, what happens? What happens during this reaction? Guaranteed heat is released. Guaranteed heat is released. So on the product side, we write. That is what I have written in the general representation. On the product side, you need to write. In O level, if you write like this, okay. But in real world, Lamai, what actually is written here is you don't write the word heat there. You have to calculate and find out how much of heat is released. Let's say 2120 joules of heat is released. Then you write it 2120 joules of heat. That is how you write. But in your level, you don't need to know how much of heat is released. So you can write just heat. The word heat. On which side? On product side. Hereafter, when we write any chemical reaction, should we write it like this? No need. When do we write like this? Only in this lesson we write it like this. Otherwise, it's not necessary to write the word heat. You don't need to write this. Only in this lesson we use it. So in the exam, when we have to write the word heat, if they talk about heat energy, if they talk about this energetic section, then you can write the word heat there. Otherwise, no need to write it. Don't worry, today when we are doing questions, you will understand when we have to write the word heat. Okay. Go to the tube. General representation. There is a box given. I want you all to write the main reaction. Maybe you can box it inside that box. Already it's a box. Inside that box, it and write it. And then write the example. I'll go through your questions. So do we need to write the notes in our tutorial class? No need, Puta. If you want, you can write it in a separate paper and keep, because however we'll be doing it in the physical class, right? So how do we find out whether a reaction is exothermic or endothermic? By practical methods. I will separately give you all what are the exothermic reactions, what are the endothermic reactions in our syllabus. From that you can find. Yeah, again, how to identify exo-endo? How to identify exo-endo? That's the main question most of you have. Now don't worry. Now don't worry how to find out whether a reaction is exo-endo. At the end, I will tell what are the exothermic reactions in our syllabus, what are the endothermic ones. So can the excess or extra energy be greater than the product energy in any circumstance? Yes, possible. That is what endothermic reaction is. I'll come to that. So when the reaction happens, the whole energy will be released. So there will be energy left in the reactant. There will be energy left for sure. Because products are having the bond. In that bond already there will be some energy. That's why there is 3000 joules of energy. But that excess is only released. Should we write this example also in the box? Yes, write it in the box. Once done, tell me done, right? YouTube people also. I am going through the chats. So can you move a bit? Okay. Balance it and write it, eh? Okay, no? Right. So remember, during exothermic reaction, reactants have more energy, products have less energy, that excess energy is only released. Keep that in mind. Reactants have more energy, products have less energy, that energy, that excess energy is only released. That put it to the mind and keep very careful in a mind. In exothermic reaction, reactants have a greater energy than product. Please underline or highlight. Please underline or highlight. Right. Perfect. Energy level diagram. Stop all your other work now. Stop everything. Look very carefully. Look very carefully. No point am I playing the Zoom or switching on the Zoom and going and watching something else. One in data is also wasted, on the other end, your time is also wasted. If you are sitting here, properly sit, these 2.5 hours, you have to put the things in the mind and only go. Otherwise, it's a huge time waste. 2.5 hours, such a big thing you can do in your life. Life changing time is 2.5 hours. In that, such a big thing, such a big changes you can do. So in case if you are doing something else, you think better. So don't try to fool yourself. Properly sit and listen. And now the most important part of this lesson, kind of part of this lesson, energy level diagram. Energy level diagram. Right. Listen very carefully. Next 10 minutes only you won't understand anything. But when I finish the explanation only you will understand. Energy level diagram. What you are going to do here? You are trying to represent this exothermic reaction using a diagram. That means using a graph you are trying to represent. Right. Now, during exothermic reaction, what happens? Reactant is there, or there are several reactants. They convert into products or several products. I'll allow you all to unmute from this point onwards. Properly use the mic. Now you all tell me. Exothermic reaction. Reactants are converting into product. Heat should be written in which side? Product side or reactant side?
Product.
Products.
I can't hear you now.
Product side.
Product
Product side, sir.
side.
Now tell.
Side.
Side.
Product side.
Product side. Product side. You
side.
write heat. Why Putta you write product side heat? That is because reactants have excess energy or less energy?
Excess energy.
Excess energy.
Energy.
Excess
Product-
energy.
products have less amount of energy. That remaining energy is only released. How to draw energy level diagram for this? Now mute yourself. How to draw energy level diagram for this? Listen very, very, very carefully. In an energy level diagram, you have only y-axis. You have only y-axis. Y-axis is your vertical axis. Then first you draw the y-axis. It's the vertical axis. Y-axis is the energy axis. Y-axis is the energy axis. So you draw a vertical line, right energy. You all tell me in the y-axis, if I take points, you all already know from maths, when you go upwards in the y-axis, the value increases.
Increases.
Wait, now mute yourselves. When you go upwards in the y-axis, the value increases. That you all already know. When you go upwards, the value will increase. I take a point here. This point has high amount of energy. This point has less amount of energy. Mathematically correct? This point has high energy. This point has less energy. Now you all tell me during exothermic reaction, reactants are there, products are there. Who has high energy?
Reactants.
Reactants. Then who should be written on top?
Reactants.
To write it, Lamai, we draw a line. We draw a line and write reactants. Or reactants. Why did I write reactants on top? Because it has more energy. Who has less energy?
Product.
Then product you write on bottom. Product or products you write on bottom. Don't misunderstand anything. This line is x-axis. Wrong. We don't have x-axis energy level diagram. Only y-axis is there. This one we are drawing so that we can write the word reactant and product. That is why we draw this line. Don't misunderstand anything. There you have a x-axis. It's the x-axis. Right. Now, we are not done. Everything in this reaction should be represented here. We have written the reactants. We have written the products. We don't put this arrow. We need to put this arrow. Arrow is from where to where? Reactant to product. Or in a chemical reaction, we put the arrow from reactant to product. Reactant to product, you draw the arrow. That is also done. One more remaining. Heat energy is released. That also we need to represent it here. How do we represent it? Generally, we represent it like this. Heat released. Now everything is perfect. Everything in this reaction should be written here. Reactants have high amount of energy. Yes, it has high amount of energy. Products have less amount of energy. Yes, it has less amount of energy. Reactants are converting into product. You draw this arrow. During this reaction, heat energy is released. You write it like that. This is a energy level diagram. Okay. Now go to your tube. Energy level diagram. Now, there's a big box given. I want you all to first of all divide it into two. This big box, I want you all to divide it into two. From the center, maybe you can bend it and divide it. Right? From the center, divide it into two. Now, in the first part of the box, I want you all to write this. Whatever under the red line, including this, including that, write everything. Work. So then there is no any x-axis in energy level diagram. No, we don't have. Only y-axis is there. X-axis is not there. Once done, tell me. Are we supposed to draw the reactant and product lines as rows or just ones? No, they are just lines. It's just a line drawn so that you can write the word reactant there. So please be side. So do we need to write kilojoule per mole? Yeah, no issue. You can write the unit there. Kilojoule per mole. That's the unit we use. We calculate it in terms of kilojoules in 1 mole. Kilojoule per mole. You can write the unit 10 key. First ionization also same, no, yeah, same unit we use. Everything is defined for 1 mole. Amount of energy, joules, that is in kilojoules in 1 mole. Done. Once done, everyone tell me, yeah? Okay. In A-levels, are we supposed to indicate the calculated heat amount? Yes. You have to calculate the heat amount in A-levels. Okay. No? Right. Will they give this for your exam? No. They won't give this one. What they will give? They will give an example for this in your exam. That means, for example, see, for example, hydrochloric acid, HCl, aqueous medium, reacted with magnesium solid. Product is formed. What's the product? Magnesium chloride, aqueous, plus hydrogen gas. I'll balance the equation. 2 hydrogen, 2 chlorine. You can put 2 there. This is an exothermic reaction. So in the product side, you write heat. Product side, you write heat. There you go. Product side heat is there. We already know if it is an exothermic reaction, reactants are having excess energy, more energy. Products are having less amount of energy, less energy. They'll ask you to draw a energy level diagram for this. Don't panic. Now, whatever we learned here, we are going to apply it there. You all are going to help me. You all are going to help me, right? This exothermic reaction. How are we going to draw the energy level diagram? See, first you draw the y-axis. Y-axis is what axis?
Energy.
Energy
Energy.
Energy
Energy.
axis.
Energy axis. You can write the unit there, kilojoule per mole. I take 2 points on the y-axis, one on top, one on bottom.
Reactance.
Has high amount of energy. You all tell me who has high amount of energy?
Reactants.
Reactants.
What are the reactants here?
Reactants.
What are the reactants here?
HCl and magnesium.
Hydrochloric and
Hydrochloric and
magnesium.
magnesium.
You have to write them with their state. State is very important when it comes to energetics. HCl aqueous plus magnesium solid. And yes, sir, do we need to balance the reaction? In O level, they don't check it whether you balance it here or not. But what I yes, balance it. Then it is standard. 2 HCl, then put 2 there. So whatever here I have written. What is coming on bottom? Something that has less amount of energy. Who has less amount of energy?
Products.
Products. What are the products here?
Magnesium chloride, aqueous and hydrogen gas.
And hydrogen gas, right? States are very important. Magnesium chloride, aqueous, hydrogen. Are we done? No. Why? Only this and this are written. I told you whatever here should be written here. Now drawing the arrow. Arrow is drawn from where to where?
Reactants to products.
Reactants to product. That will never change. That is also done. Additionally, one more thing is there. What's that?
Heat. Heat
Heat
released.
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 Now, sometimes, now until now they have not given something like that. Sometimes in the exam, they will give you the value of heat released. Let's say they have given you instead of this, they have given you 2000 joules of heat is released. Then what you write here? What you write here? Now you don't need to write the word heat. You can write 2000 joules heat released. They give the value, write the value. Otherwise, no need to indicate it. So depending on the situation, you write it. So if the value is given, you write the value. Otherwise, generally what we write is heat release. That's it. That's it. 5 marks. They can go home.
Thank you.
Now, Lamai, go to the tute. Now, second part, I told you to divide it into two. No? Second part, write example and write this. Now, Lamai, try to write it without looking. Maybe the reaction you can look and write. After that onwards, try to write it without looking. Write the reaction and work. It's not expected for you to write the reaction in your exam. But can you all see when we write the reaction, it's easy to convert it into energy level diagram. Ne? So it's better if you write the reaction and do it. Work. Yeah, we need to write it in the box. Can you tell some example for exothermic reaction? Now don't worry on the examples, right? Still we are learning the concept only. I'll go to the example once when you are done with this lesson. Once done, tell me done. Try to work without looking. States are a must. It's a must to indicate the states. Okay. No? Okay. Right. Right. Perfect. That's it. Exothermic reaction. Now y'all are going to help me. That's it. Exothermic reaction. Now I'm not going to explain. Y'all are going to help me to explain. Exothermic reaction, heat is released. Now going to endothermic reaction. Heat is
Absorbed.
Absorbed.
Put it into a nice sentence now. The chemical reaction in which heat energy is
Absorbed.
Absorbed
is
is endothermic
endothermic
reaction.
reaction. Write it there. Chemical reaction in which chemical reaction in which chemical reaction in which heat energy is heat energy is absorbed absorbed is endothermic reaction is endothermic reaction is endothermic reaction. Huh. General representation. Before going to the general representation, you as an observer, what you will observe during an endothermic reaction. What you will observe during endothermic reaction. Now see Lamai, inside the beaker, let's take endothermic reaction is taking place during the endothermic reaction. Heat energy is absorbed. Heat energy is absorbed. Again, heat is going. It is going from that place. Heat is being lost. Surrounding heat is lost. Once when the heat goes, once when the heat leaves from the surrounding will become cool. Correct? When heat leaves from the surrounding will cool down. So when you touch the beaker, you feel that the beaker is very cool. Why? Heat from the surrounding is going in. Okay. Now I know some fellows will be thinking like this. Answer. When it goes in, when we put the hand inside, now inside will be hottening. Some fellows are thinking like that. No? When outside heat goes inside the beaker, now inside will become hot. No? Hurry, you think outside will cool down, inside will become hot. No, no lamai. Where is this heat energy going? Don't think it like heat energy. It is going inside as chemical energy. It is going into the chemical bonds. That energy goes into the chemical bonds. Don't think that chemical bonds will become heated. No, not like that. This energy that is absorbed, quickly it goes inside the bond. You can't feel that energy. Outside there was energy, outside there was heat energy, suddenly it's lost. Where is it? Inside the chemical bonds. So even when you put your hand inside, you can't feel that inside is hot because once when it is absorbed, it goes into the chemical bonds. Okay, understand that point. Don't think that the inside it will be heated. No, 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 no. Heat is, there is no heat transfer happening here. Heat energy is absorbed and it's going into the chemical bonds.
It goes into the bonds. Previously, bonds were broken, that energy released as heat energy. Now, outside energy is absorbed, it goes into the chemical bonds. So bonds are formed. Yeah, it goes inside the bond. It's stored in the chemicals. So don't think inside will become heated. No, it can't happen. Now only it makes sense. Now don't think that way. Once when the heat is absorbed, now don't think heat here, it is going and staying inside. No, it's not going and staying inside. It goes into the chemical bonds. So it's like this. Heat or it disappeared. Something like that is happening. Annahari. So it is that going inside and hides inside the one where we cannot find it. Yeah, you can't find it. That is what is happening. Okay. So that way you need to think. That's why I told you this lesson is totally different to the other chemistry lessons. You can't think it in the normal way. Now, until now, small brains, what you thought? When heat goes inside, heat will be inside. No. Heat goes in and it is stored inside as chemical energy. That is what is happening. Okay. Right. So surrounding will cool down. Inside, whatever the chemicals there, inside that there will be energy stored. Now general representation. Now general representation. Any chemical reaction, reactants of reactants are there. They convert into product or products. During any chemical reaction, reactant or reactants, they react and convert into products. Now during endothermic reaction, heat is absorbed. Now think. Heat is absorbed. Heat is absorbed. Heat is like needed for the reaction. Heat is like a reactant now. Without that heat, this reaction can't proceed. Those bonds can't be made. That heat is now needed for the reaction. It is acting like a reactant now. Which side should I write it? Left side or right side? Reactant side. This side I need to write. Why did I write the heat in product side before? Because before heat is released, it's like a product. Now, why did I write it in the reactant side? Because heat is needed. It's like a reactant. Without this heat, this reaction can't proceed. If this heat energy is not given, this reaction won't proceed. So, absorbing this heat energy only, reaction will proceed. For example, let's take reactants are having 3000 joules of energy. To form the product has 5000 joules of energy. Inside reactants, there is 3000 joules of energy. Inside products, there is 5000 joules of energy. Then you all tell me, for the reactants to convert into product, how much of heat needs to be absorbed? How much of heat needs to be absorbed? Perfect. Additionally, it needs another 2000 joules. Without this reaction can't proceed. For example, let's take, in your pocket, you have 3000 rupees. In your pocket, you have 3000 rupees. You wanted to eat pizza. I don't know what kind of pizza it is. 5000 rupees pizza that is. You all tell me. Just with this 3000 rupees, can you eat a 5000 rupees pizza? No, you can't. How much you will ask from your father? How much you need from father? Again 5000. You have 3000. No. I think of the father. How much? If you are a good boy or a good girl, You will take 2,000 rupees from the father. Naughty fellows will take fully for the 5,000 from the father. එහෙමත් ඉන්නවා ඈ. එතකොට you need additional 2,000. Without this 2,000, you can't proceed. Same way. Reactants have 3,000 joules. Products are 5,000 joules. Without that remaining 2,000, this reaction can't proceed. It won't go. That's why it absorbs from the surrounding. Now you can take it from your father or from your surrounding only, you will take. Okay. Now think. Now think. Now think. Now think. Now think. Who has excess energy? Who has lot of energy? I'll use the word lot of energy. So is it reactant or product? Who has lot of energy? Who has lot of energy? Product have lot of energy. Who has little bit of energy? Who has less energy? I'll allow you to unmute it easy. Who has less energy? Reactants have less energy. So that remaining energy is only supplied and this reaction will proceed. Directly opposite to exothermic reaction. Exothermic reaction, see, products have less energy. Endothermic reaction, products have more energy. Exothermic, reactants have more energy. They are have more energy. Simply remember it like this, Lamai. Now listen. If you write the word heat in the product side, more energy is in reactant side. Listen to the words I'm using. If you write the word heat in the product side, opposite side will have more energy. Reactant side will have more energy. Correct? No? If it has more energy only, it can release. So heat in product side, then more energy is in reactant side. Same here. Heat in reactant side, then product has more energy. So you write the word heat, opposite side will have more energy. If heat is written in reactant side, product will have more energy. If heat is written in product side, reactants will have more energy. So go with that opposite connection. Okay. Yeah, another person was telling where there is heat, there is less energy. That way also you can go. Where there is heat, there is less energy. That way also you can go. Good. Go to the tube. We wrote the definition for endothermic reaction. In that box, write the general representation. Write the general representation. If you want in a pencil, you can write reactants less energy, products more energy. Work. So, sir, if this reaction is made inside a very cool environment, I'll talk about this question and go. So, sir, if this reaction is made inside a very cool environment, will it happen because it cannot get the heat from the environment? I'll ask a question. Can you cook without heat? Can you make chicken? Can you make chicken curry without heat? Without supply? Without supplying heat from any source. It need to be a cooker from solar energy or something from there. Air fryer, whatever. Can you cook without supplying heat energy? No. Why? Cooking is endothermic. You're cooking food there. Actually, there is a reaction happening there. Food, it absorbs the heat. You need to supply heat. Without you can cook. Reaction won't proceed. Okay. No? Now we'll go to the energy level diagram. Energy level diagram. Right. Energy level diagram. For endothermic reaction. Right. During endothermic reaction, we know reactant or reactants are converting into product or product. Heat is absorbed, you write heat in the reactant side. Energy level diagram. We have only the y-axis. There you go, y-axis. Tell me, y-axis is what axis?
Energy.
Energy.
Energy axis. Measured in kilojoule per mole. We take 2 points, one on top, one on bottom. You all tell me, endothermic reaction. Who has greater energy? Heat is written in this side, opposite side, energy greater. Reactants have less energy. So who is written on
Product.
product or products? What comes on bottom?
Reactant.
Reactant or reactants. This is written. Going to the arrow. Arrow is drawn from where to where? Reactant to product. Always in a chemical reaction. So from down to top, you draw the arrow.
Top.
Reactant to product. That's also drawn. Heat is absorbed. Write that also. Heat absorbed now. Heat absorbed. That's it. That is the energy level diagram for endothermic reaction. in the tube. In exothermic reaction, let me cut it and make it endothermic reaction. This word should be endo. Cut it and make it endothermic. Make it endo. In endothermic reaction, products have greater energy than reactants. Underline or highlight. Products have greater energy than reactants. Energy level diagram, there's a box given. Directly draw that. Whatever under the red line, write it there. Work. No need to divide this. Directly write. So is the heat used by something after being stored in the chemical bonds? No, that bond have that energy is needed to remain in that bond. Otherwise, that bond can't exist. So what is your name? My name is Perory. That's my real name. I know you don't believe. That's my real name. Really? Why, really? Yes. Example. What's the best example? Decomposition reactions. Think. Think about decomposition reaction. Now some fellows are thinking, what is this decomposition? What is decomposition? Huh? Calcium carbonate is there. You decompose it. Can you all remember in grade 10, we draw an arrow like this? Sorry, we draw a triangle like that. What does the triangle means? What does the triangle means? Heat. You need to supply heat. Then it breaks down into calcium oxide and carbon dioxide. Can you see? You need to heat this, otherwise this reaction can't proceed. What is this reaction? Endothermic reaction. Eka vitarai the lamai. Look at the reaction I'm writing. Very familiar one for you. Someone's mic is on. On top of the arrow, what we write? Light energy. Energy is absorbed for this reaction. Without this energy, can this reaction proceed? Yes or no? Without absorbing this energy, can this reaction proceed? No.
Nope.
It can't proceed. So this is absorbing energy. What type of reaction? This is also considered endo. It's not absorbing heat energy, but somehow it needs energy. Without that, it can't go do this reaction. It's an endothermic reaction.
Yeah.
Where is it? Those are examples. I'll talk about more examples separately. I'll give separately examples. Right. Hurry. HRI, with that energy levels diagram are done. Any doubt? Tell me. Hmm. Mm. All clear, no? What is the reason that this reaction take place? What's the reason? You think it's a chemical reaction. Doesn't need a reason to do the reaction. So don't we need to draw energy level diagram like before? No need, because I taught you one example. No, so now you can convert. No? Him only nang thing y'all drew. Y'all, I didn't leave space for this in the tube. Take a separate paper and draw energy level diagram for endothermic. Okay? Or we'll take calcium carbonate itself. Calcium carbonate decomposition. It will absorb heat energy and convert into calcium oxide plus carbon dioxide. You all draw the energy level diagram. This is solid. This is solid. This is gas. You all draw and put it to the chat box. Chat box. Anyway, put it to the WhatsApp group. Draw energy level diagram for this endothermic reaction. You all draw in a separate paper. Now for this, I didn't leave space in the tube. Put it to the WhatsApp group. Take a photo and put it to the WhatsApp group. When heat is released, won't there be effect on the beaker? Yes, of course. If it is a huge heat energy, beaker can have cracks. So once the heat energy is converted to chemical energy, can't it be reversed back? Yes, possible. Again, you need to do a reaction. You can get that energy out. Now, for example, photosynthesis, endothermic. What is the opposite reaction for that? Respiration, energy. Those are done. Take a snap and put it to the WhatsApp group. This one's energy level diagram. This reaction energy level diagram. Good. Put one of the group, don't put both. Good. Yeah. So who has more energy, who has less energy? First you figure out that. Once when you figure out that, you can do the question. This side heat, opposite side more energy. This side less energy. Products have more energy, it should come on top. Calcium oxide, solid, plus carbon dioxide gas. Reactants have less energy, it comes on bottom. Calcium carbonate, solid. Reactants are converting into product. You draw arrow. Heat is absorbed. Heat absorbed. Last year when my teacher was teaching about dissolution of sodium chloride, I accidentally put my finger into the beaker and the beaker was cool. Yes, dissolution of sodium chloride is endothermic. Dissolution of sodium chloride, dissolution of glucose. You put some glucose in a beaker, touch and see, cool. Perfect. Those are sent to the groups. Yes, good. Arine? Should be balanced. It's already balanced. Neither. Yes, it's already balanced. That's it. Those are the initial things about exothermic and endothermic reaction. Okay. So logically understand it. Right? Logically understand it. Don't go to memorize these things. Exothermic, heat is released. Endothermic, heat is absorbed. Heat is released. It's like a product. Heat is released in the product side. Then reactants have more energy. During endothermic, heat is absorbed. Absorbed it's written in the reactant side. Then products have more energy. That way you draw the energy level diagram. So everything is logical. Don't go to memorize these things. That's it. The theory part about this lesson. Now going to the calculation part of the lesson. Back to the board. Now going to the calculation part of this lesson. Theory part done. Calculation part. Listen very, very carefully. It probably all. Eyes on the screen, ears on the speaker, nothing else. Calculation. What are you going to do here? Right. Now, you already know during a chemical reaction, heat can be absorbed, heat can be released. One of that will happen. During a chemical reaction, heat is absorbed or heat is released. Means during a chemical reaction, a heat change. We can calculate that heat change. How much of heat is released? You can calculate. How much of heat is absorbed? You can calculate. That is what we learn under this calculation part. So what we are going to calculate? We are going to calculate the amount of heat change happening. Amount of heat change happening during a chemical reaction. For that, a very, very, very important equation. What's the equation? Q equals MC theta. Q equal, capital Q equal MC simple M simple C. This letter is a Greek letter. You call it theta. What are theta. One of a very, very famous equation when it comes to thermal physics and thermal chemistry. Basically, thermal physics, thermal chemistry is ruled by this equation. It's like a monopoly equation. One of it's one and only equation that rules full thermal chemistry, thermal physics, both. The full heat part is ruled there. Q equal mc theta. Very famous equation. I'll first introduce you all the letters here. Q. What is this? Q means Q is the heat change happening. That is what you are going to calculate here. So heat change is Q there. Heat change is the Q there. What does simple M stand for? It's a usual notation. Usually simple M is used for what? Mass. What mass? Total mass there. Total mass of the reactants. That is what is taken there. Total mass of the reactants. Total mass should be taken. These words are very important. Eh? Total mass is taken. What does C stand for? Simple C means lamai. Specific heat capacity. What does simple C stand for? Specific heat capacity. Don't go to think much about specific heat capacity now. Because in your next lesson is heat. Under heat, we'll be deeply learning about what is specific heat capacity. Now, even if I tell the definition, you won't understand. What's the definition of specific heat capacity? Amount of heat necessary to increase the temperature of unit mass of a substance by 1 degree Celsius is specific heat capacity. You won't understand it by definition, I know. But I can tell something like this. Specific heat capacity is something like this, Lamai. Simply, how much you need to heat a substance to increase the temperature. How much you need to heat a substance to increase the temperature. How difficult is it to increase the temperature of substance by heating? For example, we'll take petrol and we'll take glass. Petrol and glass. You all tell me which one is easier to heat and increase the temperature? Which one you can easily heat and increase the temperature when you compare petrol and glass? See, practically think, don't think like scientists now. Petrol and glass, which one you can easily heat and increase the temperature? Petrol you can easily heat and increase the temperature. IA. Now, glass, it's hard to heat it and increase the temperature. Glass, it's hard to heat it because specific heat capacity is high there. Petrol, easy to heat because specific heat capacity is low. How difficult is it to heat a substance? It's very difficult to heat glass, so its specific heat capacity high. It's very easy to heat petrol, specific heat capacity low. Now your turn. You all compare and tell me. Kerosene and diamond. Which one specific heat capacity is high? I'll allow you all to unmute. Which one specific heat capacity is high?
Diamond.
Kerosene.
Specific heat capacity is high.
Diamond.
Diamond specific heat capacity is high because it's very difficult to heat it. Kerosene specific heat capacity is low. It's easier to heat. For now, put it to the mind like that. What is the specific heat capacity? How difficult is it to heat a substance? Just keep in the mind like that. Later, I will teach separately the definition, how it gets connected, all those things. Right? For now, how difficult is it to heat a substance? If it is very difficult, specific heat capacity is high. If the difficulty is low, if it is easy, specific heat capacity is low. That is that specific heat capacity. Finally, theta. What does theta stand for? What does theta stand for? Theta is temperature change. That word is very important. Temperature change is theta. So you multiply m by c by theta, you can get heat change. What are their units? What are their units? Heat change. Heat nilamai. Heat is an energy. What's the SI unit for energy? What's the SI unit for energy?
Joule.
Joules. Capital G. Total mass. Total mass is mass. What's the SI unit we use
Kilograms.
to measure mass?
Kilograms.
Kilogram.
Kilogram. So sometimes, Lamai, sometimes in the question, they will give the mass in grams. Then what you do first? You convert it into
Kilogram.
kilogram. Specific heat capacity, there are two units.
Kilojoule minus
JKG
Joules
minus 1 degree Celsius minus
per
1.
kilogram per degree Celsius or
Or
joules
Kelvin.
per kilogram per Kelvin. Two units are there. When to use what unit, I will tell. Joules per kilogram per degree Celsius, joules per kilogram per Kelvin. Two units are there. I will tell when to use what unit. Now don't get panic. Some people they get panic when you see when they see a big unit. Don't get panic. Once when you do the questions, you will get familiar with it. Temperature change. That's temperature. Measure temperature. There are three units, but we use mainly two units: degrees Celsius and Kelvin. Now think. If the specific heat capacity is given in joules per if the specific heat capacity is given in joules per kilogram per degree Celsius, then you take the temperature change in what unit? Celsius or Kelvin?
Celsius.
Then you take it in Celsius. If this is given in Celsius, here also you take it in Celsius. If specific heat capacity is given in joules per kilogram per Kelvin, then temperature change should be taken in what unit? In Kelvin. So depending on what is given, you take the temperature change unit. Total mass, in case if it is given in grams, you convert it to kilogram. Then only you will get the final answer, heat change in joules. So everything should come into the same units. Here also, see, here should be kilogram, then only this also be kilograms. These two should be kilograms. Otherwise, you can't get the final answer. I know you won't understand it now. Mathematically, I will tell it once I start doing the questions. Just for now, keep in mind, everything should be in the same unit. For now, just keep in mind. Once when I start doing the question, I'll explain you all deeply. So again, calculation part, we are calculating the heat change. Heat change Q is equal to MC theta. Simple M, simple C theta. That's how you write. Simple M is total mass. Simple C is specific heat capacity. Theta is temperature change. You multiply all those three, you will get heat change. Heat change is in joules. Total mass should be in kilogram. Specific heat capacity, two units are there. Depending on the temperature change, you select the unit there. Calculation. Here we'll be calculating the amount of heat change released to absorb during a chemical reaction. Now, Lamai, there is a box given neither. I want you all to divide it like this. I want 1/3 of the space there. Now, this is not half. No? 1/3 of the space I need to write something. 1/3 of the space I need. In the 2/3 of the space, now don't keep rulers and measure it, just with your visual measurement, take it. 1/3 of the space I need, 2/3 of the space, you're going to write that equation, box it, draw butterfly, flowers, everything around it. Under that, define what are they with their units. And if you want in a side, write down, this is theta. Work. So are you doing online classes regularly? Yes. Saturday night, 7:30 to 10 p.m. It's interactive class time slot. If anyone wants the class details, you can text to this number. This is my number. If I don't reply it, text to this number. Once done, tell me done. Okay. Done. No? Sometimes, Lamai, in the questions, this temperature change won't be directly given. They won't give you the temperature change directly in the questions. In that case, you might need to calculate the temperature change. You might need to calculate the temperature change. How to calculate temperature change? Y'all tell me. How to calculate a change? Mathematically tell me. How to calculate a change?
Final temperature minus
Temperature
initial
minus initial
temperature.
temperature.
To calculate a change, you subtract the final with initial. Now, for example, to calculate velocity change, final velocity minus initial velocity, you get the velocity change. Displacement change, change in displacement, final displacement minus initial displacement. Change in acceleration. Final acceleration minus initial acceleration. Now you all tell me about temperature change. How to calculate it?
Final
Final
temperature
temp.
minus
Initial
Final
tempo.
temperature minus
Initial tempo.
initial.
Initial
Any change is
temperature.
calculated by subtracting the initial from the final. Symbolically, if I write down, theta is equal to TF, final temperature, minus TI, initial temperature. That way you can calculate the temperature change. I told you, 1/3 space leave here. In that space, I want you all to write. In that 1/3 space, I want you all to write. Maybe you can box this. YouTube people, while you all are watching, please subscribe to the channel and go. I'm at the final countdown. Another 100 subscribers, we can hit 5K. I can remember I started with only about 10 or 20 subscribers. Initially. Hurry. Temperature change equal final temperature minus initial temperature. We'll do some questions. Nothing big. Nothing big. See, now see, will you listen? Will you? Now, for example, see, let's take there's a reaction happening. Total mass of the reactants are 2 kg. Just listen, Total mass of the reactants are 2 kg. Let's just imagine specific heat capacity is 3 joules per kilogram per degree Celsius. Temperature change, directly they have given 2 degrees Celsius. I have put some easy numbers to initially start it. Mass is given, specific heat capacity is given, temperature change is given. Let's take, they are asking, what's the heat change happening here? We'll calculate and see what's the equation. Q equal MC theta. When you all are doing the question, always start by writing the equations. Very important. Always start with the equation. We need to calculate Q. Mass is given 2 kg. Write the mass with unit. Some people just write 2. Wrong. 2 is a number. 2 kg is the mass. Multiplied by specific heat capacity 3 joules per kilogram per degree Celsius, right, with the units, multiplied by theta. How much is theta? 2 degrees Celsius. Now, Lamai, this is a baby question. First, we'll deal with the numbers. 2 into 3 into 2. How much?
12.
12. Nothing big. 12. Check with the units. Now, look at the units. Kilogram per kilogram will cancel out. Correct? No? Kg to the power plus 1, kg to the power minus 1 will cancel off. Degrees Degree Celsius per degree Celsius. Cancel off. Degree Celsius to the power minus 1, cancel off. What is the unit we are having now? What's the unit remaining? Joules. Correct? No? Q is heat change comes in joules. Now can you understand why did I tell mass should be in kilogram? Here these two units should be same. Now can you understand? If they are not same, can you cancel it like that? Get the final answer correctly.
No, sir.
No. So that's the reason. That's the mathematical reason. There when I was telling, I told you, you won't understand it then. Now you would have understood. So that's it. You think this is a big question. Just multiply and get the answer. Surely will come for the exam. Surely score it. And this section never give up. We penna the right. Only one equation is there. You equals empty theta. Nothing else. No any other equation. Okay. Write it and get the answer. That's it. Sometimes temperature change won't be directly given. If so, they will give final temperature, initial temperature. From there, you can get it. And sometimes they will play with the mass. About that, I will talk separately. We'll start doing the question. Take the question tute. Maybe question part. Ayyo, what did I click? Dingala. I will give you all 2 minutes. Start doing question 1. Put it to the group. Start working. And now don't give up. Now you all know the theory. Oh yeah, don't go to sit, relax. Now work your fullest. Train your brain. That will only build your brain. Otherwise, your brain won't be built. I can do this question. You don't wait until I do. You train your brain. Read. Get the important parts. Start doing. Work.
Sir, should we do only the first one?
Yeah, for now, just do the first one. Screen is not clear. You can use your tutor. I will make it bigger as much as possible. Yeah, those who found the answer, those who can take a photo and put it to the group. I can go through your calculation part. Don't just sit and wait. No point. Good. Perfect. I'll start doing the question. Right. First, Lamai, when you get these types of question, now those who are wondering, listen. When you get these types of question, read. Essay type question, read. Then you extract the important data. See how I do this. Calculate the heat change. Calculate the heat change. That means they are asking the Q value. That's what they are asking. Calculate the heat change kyanne, no doubt. They are asking the Q value. Q how much? Right. occurred when an acid and a base of total mass is given 2 kg. Total mass 2 kg. Total mass is given 2 kg. Is reacted in a closed system. Temperature change occurred. Temperature occurred is given during the reaction is 3 degrees Celsius. Specific heat capacity of water 4200 joules per kilogram per degree Celsius. So important data are there. Temperature change is there. Specific heat capacity is there. Temperature change. Temperature change is there 3 degrees Celsius. Specific heat capacity is there 4200 joules per kilogram per degree Celsius. Now I don't need to read the question again. All what I need are there. Apply the equation Q equal mc theta. Substitute the values with the units. M is how much? 2 kg. Kg is important. C specific heat capacity. Big numbers are there. Don't panic. 4200 joules per kilogram per degree Celsius. Theta value is there. 3 degrees Celsius. Now maths. 2 into 4200 into 3. 2 into 42 is 84. 84 into 3. 80 into 3. 200 and 240. එතකොට 84 නේ 240
So is that 25,200?
into 3 somewhere 50 50 something is coming නේද 4 into 3 12
Andy, you're
එතකොට
correct.
252 ද 252 something 252
252
Yes,
double
sir.
zero.
Double zero,
252
name.
double zeros.
252 double zero. Don't panic with the maths. Maths will come everywhere. Check with the units. Kilogram per kilogram cancel out. Degree Celsius per degree Celsius cancel out. Final answer comes in joules. That's it. Maybe numbers would look big. Maybe don't get panic. Slowly sit and do. Go to the second one. Second one, be careful, be careful, be very, very careful, be very careful. Given in
finish.
grams. They have not given the total mass, separately the masses are given. Do will you first, you all do will you? Those are doing the first one, I will keep the screen for 30 seconds. Do it. Others go to the second one. I'll put the screen for the second one. Be careful, given in grams and total mass is not given. Put to the chat box as well as to the WhatsApp group. Good. Yes, I'll start the discussion. A acid of mass 25 grams and a base of mass 25 grams. were reacted in a closed vessel. Acid 25 grams, base 25 grams. In a closed vessel, you have acid 25 grams, you have base 25 grams. First tell me, what's the total mass of the reactants? Total mass is 50 grams. So total mass is only 50 grams. We need the total mass. Why? Equation is defined for what? Total mass. Were reacted in a closed vessel and the temperature change. Temperature change is 5 degrees Celsius. Calculate the heat change. Specific heat capacity is 4200. Temperature change is there 5 degrees Celsius. Specific heat capacity is there 4200 joules per kilogram per degree Celsius. They are asking the heat change. Be careful, mass is in grams. That's the only problem. That we can start, I think. Apply the equation. Q equal mc theta. You need to find Q. Mass is 50 grams. 50 grams. Grams, you need to convert to kilograms. Grams to kilogram, what you do? Multiply or divide by 1000. Gram to kilogram, what you do? You divide by 1000. This grade 6 maths, eh? 50 gram divide by 1000, you get the kilogram. I'll write it directly like that. 50 over 1000 kilogram. I'm not going to do the math here. Directly, I write it as 50 over 1000. Multiplied by. Specific heat capacity 4200. Joules per kilogram per degree Celsius. Temperature changes 5 degrees Celsius. Neither. Oh. Now see. 00, 00 cancel off. Another 10, 10 cancel off. 5 into 42. 210. 210 into 5. 200 into 5000. 10 into 5, 50. Q is equal to 1050. Check the units. Kilogram per kilogram cancel. Degree Celsius per degree Celsius cancel. You get the answer in joules. Okay. Some fellows are wondering, sir, why did I write it like this? Okay, then you write it in the normal way. 50 over 1000 is 0.05. Write it that way and do the math. That doesn't matter. Yeah, that way is bit hard. Why? Decimals are there. No, I know you all hate decimals. Hey, Hinda, I did it this way. So writing, write it. Wait, and third question, don't go. I need to explain something before going to third question. So writing, right now. Read the third question, Lamai. Read the third question. See, during a certain reaction, temperature change was 9 Kelvin. Temperature change is given in Kelvins now. Temperature change is given 9 Kelvin. total mass of the solution with the reactant is 90 grams. Mass is given 90 grams. Calculate the heat change. Specific heat capacity of the solution is 900 joules per kilogram per degree Celsius. Marasin. Specific heat capacity 900 joules per kilogram per degree Celsius. They are asking the Q value. What's the problem here? Temperature change is given in Kelvin. Specific heat capacity is given in Celsius. If you multiply that, you can get the value. But cutting the unit, you can't cut it. There will be issue with cutting down the units. Neither Celsius, Kelvin, we cut down. There we will have a problem. So what you need to do, you need to first of all convert temperature change in Kelvin into degrees Celsius. If you change this Kelvin to Celsius, then you can do the question. How to convert temperature change in Celsius, temperature change in Kelvin into Celsius? Very simple. Temperature change in Kelvin is 9 Kelvin. Temperature change in Celsius is also 9 degrees Celsius. Temperature change in Kelvin is 9 Kelvin. Now, temperature change in Celsius is also 9 degrees Celsius. Values are same. Then you all tell me. Temperature change in Kelvin is 100 Kelvin. Tell me this in Celsius. Mathematically think. Tell me that in Celsius. Annaputi, 100 degrees Celsius. No any calculations. No need to do any calculation. So temperature change in Kelvin is equal to the temperature change in Celsius. That's it. Remember that time. Temperature change. Temperature change in Kelvin is equal to temperature change in Celsius. Okay. Sorry. So what are the value now? If you get 100 Kelvin here, that is also equal to 100 degrees Celsius. If you get 10 Kelvin here, that is also equal to 10 degrees Celsius. Remember that, right? Again, I repeat, temperature change in Kelvin equals temperature change in Celsius. Again, one more time, I'll repeat the word. Temperature change in Kelvin equal temperature change in Celsius. Change is initial minus final. So that change value is only equal. But remember, now listen, remember, temperature in Kelvin and temperature in Celsius are not equal. Seen, eh? Two different words. Look at the words. They are not same. Temperature change in Kelvin equal temperature change in Celsius. Temperature in Kelvin not equal to temperature in Celsius. This is why some fellows, those had done your next lesson, heat lesson. You all are wondering with a number called minus 273 plus 273. That comes and affects us when it comes to this logic. Or minus plus 2, that number 273, that doesn't come in temperature change. That comes in temperature. I know you won't understand now. Until we finish heat lesson, you won't understand. So don't get your mind upset with 273. That number. You won't understand it now. Now just keep in mind, Temperature change in Kelvin is equal to temperature change in Celsius. Change is minus initial. This is just temperature. Temperatures are not equal. Temperature changes are equal. That means that difference, that gap is equal, not the temperature. Okay. Gap is only equal. Change is only equal. That difference is only equal. Not the temperature. No, not the temperature. So if we continue with that question, 9 degrees Celsius in Celsius. They're asking theta value. Now you can do the question actually. I'll give it a start. To apply the equation Q equals MC theta. Q is there. M is there in grams. You convert to kilograms. 90 grams equal how many kilogram? You divide by 1000. What you divide by 1000? 90 you divide by 1000. So 90 over 1000 kilogram. Specific heat capacity 900 joules per kilogram per degree Celsius. Theta value 9 degrees Celsius. Do the math. Find the final answer. You all work. Do the math and find the final answer. Good. What happens? 1, 2, 3, 0. 1, 2, 3, 0 cancel off. 9 into 9 into 9. 9 cube. 9 cube is how much? 729. Need. 9 into 9 into 9 is 9 cube. 9 cube is yes, 729. Check the units. Kilogram per kilogram cancel off. Degree Celsius per degree Celsius cancel off. Joules will remain. 729 joules. Harne? Doubts until there? Any doubts until there? All clear? If initial temperature is not given, we must assume as 0. No, you can't assume it as 0. If initial temperature is not given, then they are expecting you to find the initial temperature. The initial temperature. Then final temperature will be given, M will be given, C will be given, Q will be given. Q given, M is given, C is given, final is given, you can find the initial. Okay. What do you mean by closed system? Closed system means what inside the system doesn't go out. Whatever inside the system doesn't know. Open beaker, it's an open system. Beaker with a lid, it's a closed system. We did question 1, 2, 3. Neither. Your homework, I want you all to do 4, 5, 6. 7, 8 වගේ නම් ළමයි try පට්ට questions පට්ටම questions 8th question 9th question 10th question right පට්ට questions next week in the normal theory class right normal theory class in the normal interactive class I'll be discussing all these questions right now do this as a homework 8th question especially 8th question 9th question 8th question all big things are there for you to think. Thinking is there. Thinking part is there. Big thinking part is there. Hurry. So give a try. Right? Give a try. 1 week is there. I guess Monday is also a holiday. You have enough and more time. Right? Sit, think, do. That is for your homework. Before we finish can now interactive students don't leave. Our normal interactive students, because you all know from yesterday a small 5-minute part is remaining for us. That one will be finishing. Others from outside, so many people have joined today. I hope all of you understood everything properly, right? I hope all of you have got some sort of knowledge, right? There is no any wastage in the time during this this thing, during this time slot, right? Hey, no any wastage, right? All of you all have, yeah, from your end also you all participated really well. So don't stop from here. This part and still day is not over. No? Day is not at all over. Just 10 o'clock. Take at least 1 hour. Sit. Try to do a MCQ paper and finish off. Don't just keep on wasting your time. Now this time, every minute is very important. I have told you. This 2.5 hours, we started just before 2.5 hours. Such a big thing we have done during this 2.5 hours. That's what I told you. 2.5 hours is enough for us to change our life upside down. So next time slot, next 1 hour, what you are going to do? Whether you are going to waste it before you go to the bed or whether you are going to use it properly. Yes, you eat. After you eat and finish, start working on something useful. Each and every second you have in your life, try to convert it to something that is useful. Don't just keep on wasting it. You sleep upside down on the city just thinking of what am I going to do? What am I going to do? If you just keep on thinking, you will not do anything. You have to get up and work. Train your brain. Only when you put more and more work to your brain will develop. Unless and otherwise, you start thinking of what you're going to do. That will never develop you. It will just keep on making you stressed. So now next week, now this tomorrow also, okay, most of the classes are not there. My class is however not there. Candy class is not there tomorrow. So don't just waste your whole day. By the end of the day, by 6 o'clock, 7 o'clock, you will realize that you have not done anything. Don't let that happen. Tonight itself plan what you are going to do for the next day. I have told you, plan out everything. Plan out what you are going to do tomorrow. Such a huge thing you can do tomorrow. Maybe by tomorrow, you can change your full results upside down. That's more than enough. So don't give up on any time slot. Keep working, right? Do that work. Our normal interact, right? We'll be continuing the questions. The others, please do the question and put it to the group. I'll just go through your answers. With that, interactive classrooms, don't leave. Don't leave. Don't leave. I will stop the YouTube live now. Interactive students, slowly. Others, enough for today then. Keep working hard. God bless you all. Please put a review about today's session. Right? You can put it as a YouTube comment or you can send me personal message about today's session. Just put a small text. Right? Okay then. Thank you and God bless you. You can leave now. Interactive students, please leave. Please remain. Please remain.